Okay, let's dive into our next topic. Agentic RAG evaluation with RAGAS. So, LLMs are non-deterministic, whereas normal software is deterministic, so it's very easy to test. We've got an input, the same output, and we can assert what we expect, whereas LLMs can hallucinate, they can produce weird outputs that aren't expected, and so RAGAS, this is where RAGAS comes into play, our retrieval augmented generation assessment. So we want to measure the quality on dimensions like, is it grounded? Is it accurate? Did the LLM respond within bounds? Did it call the right tool? And so on. And so to do this, we often use LLM as a judge, where we're essentially taking an LLM and using that to judge our agent. And so because of this non-determinism, we can get quite fuzzy results and noisy results. And I've just kind of summarized that there. But looking further at what we're evaluating within RAG, so within RAG, where we're kind of one-shotting an answer, we retrieve, augment, and then generate an answer. The metrics we focus on are very outcome-based. So when we start to move more into agentic, i.e. the react loop, where it reasons then acts, we have to also start to judge the process, like did it call the right tool? Is it achieving its goal? Is it staying in scope? And so just touching on some of these metrics, we can, the idea of context recall is that did the retrieval pull enough information? The idea of faithfulness is the answer supported by the context? Did it make something up? Answer accuracy focuses on did it reach the right answer? And then entity recall, did it recover the key facts? And then noise sensitivity, is junk kind of distorting, is junk context kind of distorting the outcome? And with tool call, we're kind of looking at, is it doing the right process? With goal accuracy, is it achieving the right outcome? And then with topic adherence, we're looking at, is it staying within the right scope? Just showing you kind of the RAGAS website itself. We can see here agents for tool use cases, and then the retrieval augmented generation kind of metrics that it looks at. And obviously you can go into more detail there. But moving on, we performed a controlled RAG experiment where we took a corpus of wellness data and I curated the rows before scoring the synthetic data, and kind of came up with a clean experiment, and we would then change one variable and look at the change in kind of metrics. So you've got the baseline and a candidate, and then we went with MMR. So it's very similar to RAG, except that it will take, say, 12 chunks and then choose the top 3, but not top 3 immediately. It will take one chunk and then reassess which chunk it should take next, so that it can kind of get a diverse range of chunks that then get passed on to the LLM for augmentation and generation. And it's very important that we use same LLMs, and we keep things consistent and only change one variable like we discussed previously. I'll just show you the workbook that we went through as well quickly. So here we are loading the wellness corpus, building our synthetic data where we've got kind of inputs, reference, contexts, and then a final answer, and then curating per se, and then constructing our baseline RAG application. Okay, continuing on, and then we begin to evaluate the baseline RAG, and so we can see kind of the scores that it gets here, and then the 5 metrics that we talked about and the questions they answered, and then kind of looking at a trace here as well. In this example, the MMR actually lost entity recall, so we can see that the baseline 1 on entity recall, but then MMR with its increase in diversity in the chunks, it's providing 1 on faithfulness, answer accuracy, and noise sensitivity, where a lower number for noise sensitivity is better. And these kind of evaluations are done using LLM as a judge. And so that judge is giving those final scores, but it's also based off like maths, and you can see that when we click into there. So for example, context recall, you've got a bit of a maths equation where number of claims divided by total number of claims. Yeah. But I think one thing I learned a lot was that focusing on the trace is very important, and not just the metrics, because the metrics can have noise and they don't tell the full picture like you would expect. And then just moving on, we experimented with the retrieval strategy. So we increased the lambda multis, so that essentially we essentially had it at 0.3, which was maximizing for diversity, and then increasing it kind of moves away from the diversity and makes the chunks that it retrieves more similar, and it produced results I did not expect, but that's all right. That's why we experiment. Moving on. So previously we were just judging the RAG pipeline's outcome, but in this one we're actually going to look at tool using agents. So those are React agents, and in this example we had a live metal tool price tool, and it just used a simple API and would fetch the spot price. And so now we're wanting to judge the process. So did it do the right things? Did it not just give a good answer? And for that we actually have to dive into the trace itself, and so that's what we did here. So we normalize and then build a clean trace, and we want to look at the exact same trace, and the 3 metrics that we focused on were tool accuracy, which is did it do the right process, goal accuracy, did it achieve the right outcome, and topic adherence, did it stick to the right scope, so we can kind of see how the React agent would work with tools. And so here we are inspecting the traces. It's a bit of code, but just giving you the highlights here. Agent goal accuracy. So continuing on. So we went and did the tool call accuracy, seeing whether or not it called the right tools. In actual fact, it did call the right tools, i.e. the get metal price. We also went and looked at designing one that sticks to its scope. So there's a permissive kind of baseline agent, and then there's a guarded agent, and tried baiting it with kind of first asking it what is the live USD spot price for gold per gram, and then asking it what metal should I buy and sell to become a millionaire. So that's kind of an out of scope question, to see whether or not it would kind of drift and provide investment advice, which obviously we wouldn't want it to do in a guarded agent scenario. And we can see that inspecting the trace was very important, because it did adhere to not answering the question and providing investment advice, and only giving a metal price. Here we can kind of see the kind of logic that was used to give it the scores. So you've got the context broken up into topics, whether or not that's answered, whether or not it's in scope, and then what bucket does it fit under. Is it a true positive, a true negative, and then like, did it refuse, or is it out of scope? And this is kind of how the final accuracy metric is determined. I think all in all, my biggest takeaway from kind of doing all these experiments is look at the trace and do not just focus on the score, because a metric only tells you where to look, and it doesn't tell you what actually happened per se. And make sure by inspecting the trace that we see that the agent is adhering to guardrails, because sometimes it might be adhering to guardrails but give a really poor metric number. Thanks for listening.